Well, hello everybody. My name is Simon Smith. I'm head of analytics at Ripjar. We're a company just based down in Cheltenham. We've now got offices around the UK, including in London, and now around the world as well. So the software I'm going to talk to you about today is now deployed in sort of 4 continents. So it's a very sort of global sort of talk really, and that's driven by financial crime. Finance is a very global thing, and obviously. We're talking today about AI, and really it's such an exciting time as a developer. I'm a data scientist myself. It's such an exciting time with these new techniques and tools that are coming into our armory all the time. But as we've highlighted, I don't know if anyone's seen this picture, but I should probably just read it out loud for those that can't read it. It says, this is ChatGPT-4. Create a picture of an empty room with no elephant in it. Absolutely no elephant anywhere in the room. Unfortunately, there is an image here which does have an elephant in the room, and I think really that's I don't know who came. Well, it's Gary Marcus on X.com, but he came up with this. I think it's such an apt illustration. I think once you see it, you can't unsee it. This technology makes mistakes. It goes wrong, and that's kind of how can we use that practically in any useful way. And really, what I wanted to do today was just give you a couple of examples of features that we've just put into our product. So just to kind of go through that, I just wanted to talk through, if you permit me, just quickly explain what our software does, that you can then understand what we've done with the technology. So we work in what's called a screening process, which is part of when you take on customers at a bank or when you've got a relationship with a customer. And what you're trying to do is, part of the preventing financial crime is to stop bad money flowing into the system. If you've ever got a mortgage before, you might have gone through such a thing, where did you get this money from, and so on. And that's very much the kind of checks that people are doing on a regular basis. And so the way these sort of systems work, this is our system, it's called Labyrinth Screening. We've got a bit of a Greek theme going, which might come out throughout the talk. But ultimately, the customer wants to know if this person on the left is risky. In this case, this is actually an Indian politician. And you put in the name, different properties, dates of birth, address. And then, this is then matching it against our data set of risky entities here. And these are the candidate matches here. So these have got some sort of identity properties in common, if you like. And this is then the risky element. This is the data connecting it to risk. And, our kind of sort of specialism as a company is producing these from media automatically. So you get all sorts of types of data, sanctions data, FBI most wanted list, all those sorts of things are checked. But we also produce our own data set, and increasingly this is being required as part of those onboarding checks, a check against media. So in this case, we've collated about this individual 910 articles linking them to risk. This is quite a big story. And then we've collapsed it down, and we've extracted, the date of birth, the gender, the name, and then we've got all the articles here that link them to risk. And so, this is our kind of system. And so analysts would then work through this, and they would say, yep, this is, I'm looking at this person, is this the same? Is there risk here? And they would go, yep, or they would go, no. And so there's this kind of set of analysts that go through these and sort of discern whether, you can or cannot have a banking product and so on. So this is just a quick introduction to kind of how our software is, and I'll then talk a little bit about what we're doing with AI right now. But just to give you a sense of scale, Ripjar has 10 billion articles going into this, so it's quite a lot of data. And it's going back 30 years, and we produce about 15 million profiles off the back of that. So we sort of really, really winnow down on what's risky, and then we then collate around individuals and organizations in this way. And big banks may then screen, that sort of left-hand side, might then screen hundreds of millions of names. The very big banks might be doing that sort of thing. And it's worth saying as well, this isn't just banks anymore. This is basically every big corporation is doing something like this, especially if you think of sort of matchmaking apps. We have quite a lot of those where they need mutual trust between the two sides to do that. And so, they might then end up with, sort of order 1 million alerts a month. So, and these are kind of being manually looked at the moment. So the sort of value proposition of this sort of software is it'll make you more efficient, finding more risk more quickly, and save time ultimately. So our sort of gambit to start with was how can we use generative AI well and safely in this space. Our users are very conservative. They don't want to miss risks. That's the number one thing you can't do. And so they're very much interested in, I need to trust this. That word trust that came up in the previous talk, very, very important here for people to actually use this software. So I thought I'd just give you a quick demonstration of how we summarize this data just very quickly. I don't know why I thought this was a good idea to give a live demo, but I feel, at a sort of tech conference, it feels, maybe necessary. Okay. I can also see it now, which is great. Basically, as we saw these profiles that are linking people to risk. This one's about Elizabeth Holmes. I don't know if you remember the story. This is the individual that set up the blood testing startup that was a complete sham, ultimately. So what we've done here is, we've gone over that 10 billion sets of news. We found all the data linking them to risk, and then we've sort of crushed them all down by identity to find all the articles about Elizabeth Holmes, and that's sort of emerging up. So all the individuals are sort of being found, in real time. We send about 2 updates a day, so these kind of, are kept up to date. So here you see we've got 12,823 mentions linking Elizabeth Holmes to risk, and then, as mentioned, that's then sort of simmered down to these news articles here, which have mentioned Elizabeth Holmes. We've got, her date of birth from the content, and then this is our summary that we produced, which is the bit I wanted to show you. I don't know if you can see it, but it starts off Elizabeth Holmes, the co-founder of the blood testing startup Theranos. And, we really wanted to, and summarizes her link to risk. And so one of the key things we wanted to do here, I'll just zoom in a little bit more so you can maybe see it. But one of the key things here is how can you learn, how can you get trust in this data? This could be complete fiction. One thing that we had from this system was that we were able to then provide data to summarize, as opposed to asking it just an open question about Elizabeth Holmes. And in this case, we've asked it to summarize the data linking her to risk. And so you end up with these she was sentenced to 11 years in prison. And we've got 2 references for that fact. So if we click on the reference here, that takes you through to the article that sort of proves that point, if you see. So that provenance is kind of kept there. And so this was our approach to how can people trust this as a key key factor that we built into it. So you then see here, Elizabeth Holmes. So I think in the summary it said she was in prison for sentenced to 11 years. Was sentenced this Friday in San Jose, California, to 11 years and 3 months in prison. So that just gives you that sort of feel for how this works. And some of the really exciting things that we got really. So this is another example of Michelle Moan. I think that's how you pronounce it. But again, this is her links to risk. I picked some stories that are quite famous, so it doesn't feel too invasive. But these are also about sort of much smaller cases as well. And so, you see here again, specific claims. Moan and her husband had £75 million of assets frozen. So you can click through here and you see, that £75 million of assets frozen is again proven. And then, just a couple more exciting ones. I'll just finish with this one, actually. So this is an interesting one because this one's covering, that international element. So a lot of the articles backing this profile are actually in Chinese, but we end up with an English summary here. So in this case, this is Zhu Jiayin, who is the former chairman of Evergrande, who, if you know the story, this is the big Chinese property developer that collapsed previously. And again, you see here with a debt of over 2 trillion yuan. And in this case, the article's actually, printed in Chinese. So I just wanted to just quickly show that. I thought it'd be fun to have a live demo, and this was relatively safe to do. So, I'll just flip back to my PowerPoint now, which probably will involve some button pressing. We'll see how we go. Okay, we're back. So we've looked at the summaries there. And so, when we were designing this, we sort of stepped back and looked at, what is it that these summaries must do for people to trust it? The only way you unlock those efficiency gains from reading less stuff is if people trust it and they don't have to read the underlying data. So we sort of set this framework up. And probably most of the work was in building the testing framework for this. It's very, very quick to try out ideas with generative AI, but building this test framework to have statistical confidence across 27 languages took quite a while, really, and that was kind of most of the work. But it does go wrong. This is actually from a bug ticket on this feature. So it just sometimes you get this thing where it sort of gets stuck in a rut, and in this case, it just repeats. You probably, I don't know if you can see it at the back, but it just says, in July 2018, he was granted bail, and it just repeats that same sentence again and again and again and again. And this is sort of, a bit like that elephant in the room at the start, people don't unsee this. So, we'd done all the statistical testing, we'd proven it out, and then you get a thing like this. And this is what I always call this, that element of trust. Issues like this cause a big loss of trust when people see them. I always call them, I've got a lot of data scientists that I work with on these things, and they always go on about statistical significance, and someone puts the thing in and go, this one case that 15 million profiles, one case, and then I always talk to them about emotionally significant errors, and I always think this sort of thing is absolutely one of those. But I think when you're talking about these technologies, you have to remember what the state of the art is, and typically it's people. And I think one of the interesting things when I was reading up on summarization is humans hallucinate too. If you ask humans to do this task, they bring their own biases, they make mistakes, they don't do it perfectly. And actually, this paper was interesting. It's quite a small sample size, but they've got a row here that says GPT-4 and human, and humans do a little bit worse than ChatGPT at summarizing articles. So, that's just really got me thinking about, what are the current processes, and how can you compare, a complex system with another complex system, which is the set of humans, a team of people doing this similar task. So the second sort of feature that we've been using is, we've got that, could we use AI to automatically and safely close alerts, automatically? So not just making it really efficient, but just, close it straight away. Now, it's an obvious feature, isn't it, really? I mean, you probably saw when I was talking about an AI topic, and I showed you that problem at the start, you probably thought this is right for AI, and you're right. The issue is that, it's quite a regulated industry, and people are very conservative about adopting new technologies and what it might do to their processes. So a lot of it was thinking about how can we get people to adopt this technology in this way. So, what is an analyst attempting to do when they go through, remember they've got that, who they're looking for, and they've got the risk on the other side. And so they're trying to say, is the person or organization successfully identified, and is the person linked to risk? That's the sort of two questions they're doing. Now, how do you frame this in a data science way? Well, the analyst then says, yep, it's relevant, or they say, no, that's not relevant. And the analyst could be wrong, or they could be right in both cases. So this is, if you're a data scientist, this is a bit of an intro, a 101 on data science, but you might have heard some of these phrases used before. True positive is the sort of, they are risky, and they were found to be risky. False positive, you said they were risky, but actually they aren't. True negative is the, they're genuinely not risky, and you said so. And false negative is you missed it. So obviously this has a cost implication. And so, these are the positive ones, the ones that start with the word true, and these are the bad ones that start with the word false. Sorry, just a bit of a lag there. There we go, back. But the worst one is this false negative. This is the conservative element of the user. You don't see anything. It carries on. Nobody would ever know that someone maybe some money, laundered money is now in the financial system because of a mistake. And so people are very, very worried about these false negatives. They don't see them, and they're what ultimately lead to corporations getting fined by governments and other such things like that. So they're not just morally motivated to solve this problem well. So we ran a comparison running our, we trained a model based off an LLM that's sort of an ensemble model. And we were looking at, how well can we do this? So we had a team of 23 analysts we were working with, which were looking at, firstly, they simulated our first line. So I should just say there are different types of analysts, and that first line is that big bulk reduction in volume, and then it will get passed on to people that might make a more considered judgment. So at no point is this going to just stop people having financial services. So it's probably important to know about that sort of safety issue. But ultimately here we've got our compliance co-pilot, as we're calling it. How can we help people out with their screening problems. And then here we've got the humans, if you like, the human first line. And what we were doing here was we wanted to be, this effectiveness here is that, how good are you at finding true positives? We wanted to be way ahead of people here, just to make it very make our quite conservative user base confident in using this kind of technology. And so, for a very, very small drop in recall and effectiveness, we ended up with, getting rid of sort of 77% of the work, which is, a really good result. So that's sort of reducing the amount of work that analysts have to do by fourfold and that's the cost, a slight increase in risk. So we were very sort of pleased with these numbers. This is still ongoing, I should say. This is very, very hot off the press. So it's very much evolving in our company as well. But I think one of the other interesting things is the time, right? It's just way faster, as you'd expect, and obviously can scale quite quickly. So, this is just some early results that we're looking at in terms of, benchmarking our software against people, really, and how does it compare? It's one complex system versus another, and so and this went down very well with our user base. They wanted to see what risk, because in some ways they don't know what risks they're taking at the moment. I think, which I think is why I think people are so conservative about moving to a new technology. So I think that just hopefully just shows you a couple of interesting features that we've been working on. I hope you found it interesting. But just a few takeaways. So, it's a massive opportunity for new and exciting products and features. I think if you follow a lot of machine learning people on Twitter, I just see so many interesting ideas. I was just talking this week about Devin, which got me really excited earlier this week. Just ideas about sort of chaining things together and what could be achievable, now. I think this was mentioned, the exact phrase, mitigating risks, was talked about in the previous talk, actually. There are risks, and you've got to be cognizant of them when you're designing your talk, your software. Beware the emotionally significant errors. I think that's something I've learned from hard practice, that not all errors are equal, and data scientists have this nice four-box model that completely ignores any emotional connection and a reaction to inhuman errors. But finally, humans aren't perfect either, and I think that's kind of one of the sort of key things for me that when I've been thinking about how can we justify using some of this technology. I think that's how you do it, and I think it's just thinking about when and where, how to do it safely. But thank you very much for listening. I should say, if I can get a cheeky plug in, Ripjar are hiring for data scientists right now, so if you are interested to come and work with some of this technology, we'd love to hear from you. So thank you very much.
Thank you, Simon. Have we got time for a question, Amy? Yep, a couple of questions. Yes, please, straight away.
Hello, can you hear me? Hi, I'm Alice Violet. I was just going to ask you, I know you're working in the financial sector, which you mentioned is really regulated, but when it comes to applying technology like this in other sectors, I'm interested in what the considerations are for privacy. If, for example, like with a bank situation, I have to opt in when I apply for a mortgage to say, yes, you can do a background check on me, whereas in recruitment or any other kind of industry, it might be that they're using this data and going through this with quite intricate implications when I don't know they're doing that. And from a kind of stalk-aware perspective, what are the considerations that need to be made there?
Yeah, we're obviously in a space where, the government essentially mandates an investigation into somebody, right, a specific individual with properties. And so, in some ways, we sort of don't have to worry too much about it. But I think, in terms of what's out there, it's obviously could be misused, as we've heard. And I think, it's just, I think if you are designing systems for use, I would just encourage people to really think about, their misuse as well. And I think that's, I think that's sort of all you can do, I suppose. But I don't know if that's a great answer, but obviously these technologies could cause great harm, I think, and I think it's up to application developers to really think about how it could be misused, I think.
Simon, this is perhaps a hypothetical question, but had your software been available in 1995, do you think the demise of Barings Bank could have been prevented?
Of course, yeah. Ripjar's software is great. It will solve all your problems, I'm pretty sure. I think, Yeah, I mean, it's interesting. I think I think with it's a battle against financial crime, isn't it? And I think whenever a technology breakthrough comes through, it's not just the people trying to prevent financial crime that are using this technology. So I think I think we have a responsibility to use it well and open up new ways of tackling financial crime. I think that's where I get really excited about. There's relatively mandrolic checks at the moment, but I think you want to free up those people to be doing much more investigative work to really uncover the big scandals, the money laundering networks, and so on. I think so. I'm really hopeful that this will make using technology better will really make a dent in the problem, and ultimately financial crime facilitates all other crime, and it definitely is a great way to make the world a better place, I think. So.
Thank you so much, Simon. Round of applause, please.